viewers, thank you for joining to this lesson. Our topic today is binomial expansion. It is an area that borrows a lot from the quadratic expression and equations, under expansions, factorization and expansion. Now we have, for example, powers of a plus b. It is important to know that a plus b is an expression of two terms, that is a and b, and that is why we call it binomial expansion, because bi means it involves or rather includes two parts in the expression. There are two parts in the expression. So in this presentation, we will develop a formula to enable us to find the terms of the expansion. For example, a plus b raised to power n, where n can be any a positive integer and n represent the power or index. We call the expansion binomial as the original expression has two parts. Okay, we can now try this with the index being 2. That is a plus b raised to power 2. And a plus b raised to power 2 can also be written as a plus b and a plus b. So expanding, that means it will be a squared plus 2ab plus b squared. So with the coefficients 1, 2 and 1, we have the coefficients 1, 2 and 1 serves as the coefficients of the terms. Remember, the terms is, we have 1a squared because that is the first term. The second term is 2ab and the other one is 1b squared. So 1, 2, 1, those are the coefficients of the term, as a squared, ab and b squared, those are the variables in the expression. Okay, let's now look at a plus b raised to power 3. We do the same because this one is in three parts: a plus b, and a plus b in 3 times. So we can do the first two. That means it will be a plus b raised to power 2 and then a plus b, so that the total resulting power will be 3. So by expanding the one with the square, we get that, and then now we combine with the third one, which will be a times a squared. We'll get a cubed, and remember it comes with the coefficient. Again, a times 2ab, that will be 2a squared b, where 2 is the coefficient. And again we have a times b squared, that will be ab squared with the coefficient 1. But remember, we have the other part. We were multiplying by a. Now to finish up our expansion, let's multiply by b. So it will be b a squared b. The other one is 2ab squared, then plus b cubed with their coefficients. So we can add them to now get our resulting expansion. That is a cubed plus 3a squared b. Remember, 3 is the coefficient of the term. Then plus 3ab squared plus b cubed. So you realize that 1, 3, 3, 1, it is the coefficient of the term. So the coefficients of the expansions are 1, 3, 3, and 1. So the other one is when now we do with the power 4. When it is raised to power 4, now it will be a plus b raised to power 3 and then multiply by a plus b. So the resultant power there will be 4. So we just do the same. We multiplying by the expansion of a plus b raised to power 3, then we open with a plus b. So our resultant expansion in this case will be this after addition. So we have s raised to power 4, then we have 4a cubed b, then we have 6a squared b squared plus 4ab squared b cubed, plus b raised to power 4. The coefficient of the term 1, 4, 6, 4, 1. So this coefficient is found by adding 3 and 1, the coefficient that are in a plus b raised to power 3. That is why we get 4 there, and again we have 3 plus 3, we get 6, 1 plus 3, you get 4. Then the other ones just come out automatically, 1 and 1. So we now have that expression and coefficients are key when deriving the binomial expansion. So starting with the first one, the one that we started with, a plus b squared, the coefficients we got are 2, 1, 2, and 1. When the power is 3, the coefficients are 1, 3, 3, 1, and so on. When the power is 4, 1, 4, 6, 4, 1. So each number in a row can be found by adding the two coefficients above. So for you to get 4, we added 1 and 3. 6 is got by 3 plus 3. 4 again the same. So this is what I mean. You can look at the arrows, and that is how we derive the coefficients. The coefficient, that one is taking us through to a very a good concept of the Pascal's triangle. A concept of the Pascal triangle made of the coefficients found during the binomial expansion. So to make a triangle of coefficient, we can fill in the obvious at the top. So we have of course, we started by a plus b raised to power 2. That does not mean that it starts there. We still have others, but now we call them obvious ones. We know that a plus b raised to power 1 is still a plus b. And then also we have a plus b raised to power 0, which any number raised to power 0, it's just 1. So we can fill them here. And so we have that the triangle of binomial coefficient is called Pascal's triangle, after the French mathematician. Now we notice that the fourth row gives the coefficients of a plus b raised to power 3, but also it's easy to know which row we want. As for example, we can use a plus b raised to power 3. That means we'll start with 1, 3, then something, because it will be 1, 3, 3, 1. Again, for a plus b raised to power 10, we will start with 1, 10, and then so on, as we develop the coefficient depending on the expansion. So we need to find the coefficients of the Pascal's triangle. So that means, because we did for 6 indices, or rather 6 powers, then that means we can make a table of 7 rows starting with 1, starting with when the power is 0. So that is what we have. This is the Pascal triangle. This is the Pascal triangle, which is found by adding the ones at the top to get the one in between. So we usually want to know the complete expansion, not just the coefficient. Like for an example, find the expression of a plus b raised to power 5. So from the Pascal's triangle, we can get the coefficients, which is 1, 1, 5, 10, 10, 5, 1. This should be 10, 10, 10, 5, 1. Whereby the full expansion should be a raised to power 5 plus 5a raised to power 4 ab 5a raised to power 4 b plus 10a power 3 b square, and so on. So the power in each term sum up to 5, because if you look at the first term where we have 1 a raised to power 5, the power there is 5. The second term we have 5a raised to power 4 b. So remember, b is raised to power 1. So the sum of the powers, and the power there is 4 plus 1, that is 5. The third term also we get 5, 3 plus 2. The fourth term is 2 plus 3, which is 5. The fifth one is 4 plus 1, that is 5. And the other one is 0 plus 5, which is 5. So that is what I mean. Those powers, when we add them, you get 5. Add them, you'll get 5. Now, example number 2, write out the expansion of 1 minus x raised to power 4 in ascending powers of x. So ascending powers just means that the first term must have the lowest power of x, and then the powers must increase. The powers must increase. Okay, so the coefficient, because it was raised to power 4, so the coefficient there will be 1, 4, 6, 4, 1. Then the full expansion will be this. Before we insert the coefficient, then we replace them. So our final expansion, remember the brackets are very key, because the first term starts with 1, of course, then plus, then the second term still on the first term, of course. The first term will be 1 raised to power 4. Second term will be 4 into 1 cubed, because the powers are descending. Yeah, powers are descending. 1 raised to power 3 into x into negative x. So in that case, we will start with plus, and because x is in bracket, then it's going to affect the plus which we started with. And so if we simplify that, you get now 1 minus 4x, that is 4x. Remember, the negative you must be very careful with, because if you don't really use it well, we will not be able to get the correct sign in between the expansion. Okay, so the full expansion will be 1 minus 4x plus 6x squared minus 4x cubed, then plus x raised to power 4. So that is now when we use the Pascal's triangle, because it is from the Pascal triangle that we get the coefficients, because we are not going to to use the long expansion to be able to generate the the coefficients. At times it's become difficult, and so you need to master the Pascal's triangle, how you can get the coefficients from the triangle by mastering the addition, subtraction, and so on. Okay, so in the second part, we were doing 1 minus x raised to power 4, but we could go straight to the coefficients and then fix them on the expansion, after which we come up with the final expansion as this. So let's try another one. Let's try another one on 1 plus 2x raised to power 5. That is in the ascending powers of x. So the solution, we fix out the coefficients 1, 5, 10, 10, 5, and 1. Remember, this one comes because the power was raised to 5. And so 1 plus 2x raised to power 5, the expansion, full expansion, is supposed to be 1. And remember, we had also fixed the coefficients, so expansion becomes so easy, and then you see